We now move on to our next cipher. This one's another substitution cipher called the Affine Cipher. We're first going to review some of our other substitution ciphers, the shift cipher and the decimation cipher that we learned just recently. We're going to show how these two ciphers can be combined to create the affine cipher. And then we're going to do some sample encryption and decryption. And finally, we're going to remark upon what the appropriate keys are, very similar to what we did with the decimation cipher. All right, so remember our shift cipher. What that was, well, we took our plain text message and we converted the plain text letters into numbers. We added the key number to each of those numbers, and then we converted those numbers back into letters to give ourselves the ciphertext. We did something very similar with the decimation cipher, except instead of addition, we used multiplication. Again, we converted the plain text letters into numbers. We multiplied the key by each of those numbers this time. We again took those results and converted them back into letters, and then that became the ciphertext. So what we're going to do with the affine cipher is we're going to combine both addition and multiplication to create our key. So here's how the affine cipher works. Our key is going to be not a number like it was with decimation and shift ciphers, but a function k of x equals ax plus b. And notice that this function has both a multiplicative part, a times x, and then also an additive part, plus b. That's how the shift cipher and the affine ciphers the decimation ciphers get combined. Now in this case, remember that a and b are integers, otherwise this isn't going to work so well. Just like before, we're going to convert the plain text letters into numbers. We're going to plug each of those numbers into the key function. So those numbers are going to be our values of x. And what that means functionally is we're going to take whatever those numbers are, we're going to multiply them by the integer a, and then add the integer b to give us another number. We're going to convert that number back into letters, and that will become our ciphertext. All right, so let's see if we can use this on an actual message. So we're going to use the affine cipher. The key is going to be k of x equals 15 times x minus 8. So we're multiplying by 15, then subtracting 8 to encrypt the message, life moves fast. So first we're going to convert all those letters in life moves fast into numbers. That's all these numbers. I won't read them out to you. You can see them. You can check them yourselves if you need to. Now, the key first multiplies by 15, then subtracts 8. So we're first going to take all those numbers, multiply them by 15. These are the numbers that we get when we do that. Now we're going to subtract 8 because that's the next step of our function. And that's what we end up with there. Then we're going to convert those to remainders mod 26. And that is those numbers there. And now we can convert those back into letters to give ourselves a ciphertext. And then, of course, we want to squeeze those together so they're all in one smashed up word. So there's our ciphertext for life moves fast with k of x equals 15x minus 8 as our key. So let's move on to decryption. Now I'm going to do a completely different key. K of x equals 9x plus 4. And I want to decrypt the message. Well, I can't really read that, but you can see it right there. That's our ciphertext. First thing we want to do is convert that to numbers, just like we did before. So now we got to think about decryption in an interesting way because it's going to be a little bit more involved than some of our other ciphers. And I want to remind you how we encrypt the message so that we can run this process backwards in order to decrypt it. So first of all, we start with our plain text. I'll call it x. It's going to be some number x. We multiply that number by 9 to get 9x, and then we add 4 to get 9x plus 4. Now what we want to do with decryption is do that exact same process, except run it backwards. So for decryption, we're going to start with our ciphertext. Our ciphertext is going to be our 9x plus 4. And we want to work our way back to our plain text, which is x. Well, in order to do that, we take our 9x plus 4. We first subtract 4 to give ourselves 9x. And then we got to get from 9x down to x by multiplying by the multiplicative inverse. So we need to find the multiplicative inverse of 9 mod 26 and then multiply that by 9x, and that will get us back to x. So notice we're doing the exact same steps we did with encryption, except we're reversing each individual steps and we're reversing the order that we do those original steps. So for our multiplicative inverse, we got to play around, but it's not too hard to find. 9 times 3 is 27. 27 mod 26 is equal to 1, which means that our multiplicative inverse of 9 mod 26 is going to be 3. So that's going to help us with our decryption. So let's go back to our decryption key. If our ciphertext is x, what we want to do is first subtract 4, as we mentioned in the previous slide. That's going to give us x minus 4. And then we're going to want to multiply by 3. Remember, 3 is our multiplicative inverse, mod 26 of 9. And so we multiply that whole thing by 3. 3 times the quantity x minus 4. So our decryption key is going to be d of x equals 3 times the quantity x minus 4. And of course, if you can't stand those parentheses, you can multiply through that 3 to get 3x minus 12. Me personally, I like those parentheses. I'm going to keep them. So remember our ciphertext. I know it's been a little while because we had to do a little bit of analysis first. But those were the numbers for our ciphertext. And now we wanted to decrypt those by running it through the decryption key. So remember, our first step in our decryption key is to subtract 4. So we're going to subtract 4 from each of those numbers. That's what we get. Then the next thing we're going to do is multiply by 3. That's what we get there. Now we want to convert these back to letters, which means that we want to reduce them mod 26. We want to find the remainders mod 26. And those are easy to do individually. And then we take those remaining numbers and we convert them back into letters. And when we do that, we end up with twist and shout. So I want to remind you that just like we were doing with the decimation cipher, finding the decryption key involves finding a multiplicative inverse. So if we have our key k of x equals ax plus b, this is our encryption key. As you could probably see by running the decryption, that number a in front of the x is going to have a multiplicative inverse, right? If we want to decrypt ax plus b, we're first going to subtract b, and then we're going to multiply by the multiplicative inverse of a to get down to x. We need to have a multiplicative inverse m of the number a. Once we find that, our decryption key is, and you can think this through just like we did through our decryption in our example, we're going to subtract b and then multiply by that multiplicative inverse. So our decryption key is going to be d of x equals m times the quantity x minus b. So subtract b, multiply by the multiplicative inverse of a. And in particular, we have to actually have a multiplicative inverse of a, mod 26, which means that we have to be careful choosing our encryption keys because the GCD of our a and 26 has to be equal to 1. They have to be relatively prime. All right, so now I think you're ready to work on the activities for the Affine Cipher. That's on the PDF file included with this video.